One of the keys to success in physics is knowing the units. The units for the variables that we are measuring and using in our equations, but also the variables that result after we solve these equations. Now, the first equation that you're given is that for speed. And speed equals distance divided by time. There is a reason for this color, but we'll get to that later. Units of speed are always going to be in some form of distance per time or distance over time. Examples: miles per hour, this is on our speedometers. Meters per second is what you'll see most often in physics. The other one, the next one that they were given, was velocity. And they described velocity as speed with direction. In physics, we call this a vector quantity. We abbreviate quantity QTY. If you think back to the movie Minions, there's the criminal Vector who commits crime with magnitude and direction. That was a page straight out of physics, because in physics, vectors are variables that have magnitude and direction. So given just this basic definition that velocity is speed with direction, our equation becomes this. V equals distance over time. This is the most basic, simple form of a velocity equation. Now, my physics teacher taught me to put an arrow over the top to help me remember to have direction. And just so you know, that's a LO in case anybody's wondering. So this arrow here again helps us remember that we need to have a direction with our units when we put down what the velocity is. So our velocity units are going to be, for example, miles per hour plus a direction, or meters per second plus a direction. These directions could be up, down, north, east, west, etc., or plus or minus. I did give an example of using plus or minus because you can't exactly use the same rules as integers when you're using plus minus for directions. And I'll get more into that when we start solving things. So over here, you notice this is the most accurate actual version that you'll see of velocity. This is what you'll see more in physics textbooks, is that velocity is the change in direction. Change is represented by the Greek letter delta, the triangle, divided by time. This is the most accurate. But if it helps you for simplicity purposes to use this one, by all means, just go with this definition. So I don't know about you, but I really don't like having to use the algebra method for solving a problem in which they give me, say, velocity and distance and ask me to solve for time, or they give me maybe up here, they would give me time and speed, but they're asking for distance. I could do the algebra, but I actually was shown a easier way that does not involve algebra whatsoever. And that is, well, either circles or triangles, whatever floats your boat, dividing it up into three pieces here. This line here is always going to be a division line. This line right here represents multiplication. So then what we do is put S here for speed, D for distance, T for time. So if we needed to solve for time, our formula is distance divided by speed. If we needed to solve for distance, our equation is speed times time. So again, this circle avoids a whole lot of algebra. All you have to do is cover up, as I did, which one are you looking for. We can do the same thing down here for velocity. Create a little circle. Like I said, you could do the triangle way. I like circles. So then we do velocity, again, the arrow to remind us of direction. You can either put d for the simplistic version, or you can do this one where it's change in distance, and then time would go right here. So if we needed to solve for time, we cover up t. Now we've got distance divided by velocity. If we needed to solve for distance, we've got velocity times time. No algebra required. So, big picture here of what we got so far. And let me go there. And I'm going to count or watch my time